All right, let's talk about AI's biggest secret. And it's gonna sound weird. The smartest AI isn't actually the most complicated one. In fact, it's often the simplest. And it all boils down to one kinda crazy question. So here it is. How can a simple, boring straight line be smarter than a super advanced complex AI? I know, it sounds totally backward. It feels like it shouldn't be possible, right? But stick with me, because the answer to this question, it reveals maybe the most important single idea in all of machine learning. Okay, so to get our heads around this, we gotta cut through all the jargon, all the hype. Because when you boil it all down, what machine learning is actually doing, well, it's surprisingly simple. At its very core, it's just about making predictions and classifications. That's really it. You know, stuff like, is this email spam or is it not? Is this stock gonna go up or is it gonna go down? It's not magic, not at all. It's just a really, really powerful tool for sorting things and making educated guesses based on patterns it's seen before. So let's see a simple classification model in action. Let's pretend we're trying to predict if you are gonna love the YouTube channel StatQuest. A super simple way to do this is with something called a decision tree. And all it does is ask a bunch of easy yes or no questions. So first question, do you like silly songs? If you say yes, it asks the next one, are you into machine learning? If that's a yes too, then bam, the model predicts you're gonna love StatQuest. But what if you weren't into machine learning? Well, it'll try another path. It'll ask, okay, how about statistics? If that's a yes, then hey, you'll still love it. See what's happening? It's just a simple flowchart, a really basic, straightforward model. All right, so that's a simple model. Easy enough. But what makes any model, whether it's simple or ridiculously complex, actually good? Well, that leads us to the ultimate test. Okay, let's switch gears to a prediction example. And this one's kind of fun. Imagine we start measuring how many yams people eat versus how fast they can run. I know, weird, but go with it. So we plot the data, and a pretty clear trend shows up. The more yams you eat, the faster you run. We even got a data point way up here for Usain Bolt, who apparently eats a ton of yams. Now, this first batch of data we've collected, this is what we call training data. And the name is perfect, because we literally use it to train our AI model. We're showing it, hey, look, this is what the connection between yams and running speed looks like. Okay, now this is where it gets really interesting. We've got two choices for our model. We could draw this simple black line that kind of follows the general trend of the data, or we could use this wild, complex green squiggle. And just look at this thing, it's like a work of art. It perfectly twists and turns to hit every single data point. It misses absolutely nothing. So, I mean, the green squiggle is obviously better, right? It's literally perfect. It's nailed the training data flawlessly. This has got to be the smarter model. Case closed. But hold on. This is where we run smack into the golden rule of all AI. The real test of a model isn't how well it remembers the data you showed it. No, the real test is how well it predicts things it's never seen before. And for that, we need new, fresh data, which we call testing data. All right, this is the moment of truth. Let's throw some brand new data points at both of our models and see which one actually comes out on top.
And here it is. This is the big secret. The simple black line, its predictions are actually pretty close to the new data points. Not bad. But the perfect green squiggle, oh, it's a total disaster. Its predictions are way, way off. So what happened? Well, it didn't learn the actual trend. It just memorized every little bump and wiggle, the noise, in the original data. And in the world of machine learning, this huge mistake has a name. It's called overfitting.
Just like our source at StatQuest says, even though the green squiggle looked better on the training data, the black line did a better job predicting. The simple model won. And that's because the real goal isn't to perfectly memorize the past, it's to be able to generalize and predict the future. So what is the one big takeaway from all this? What's the secret we've been talking about? It really just boils down to one key idea. Okay, so here it is. The real goal is always to make accurate predictions on new data. The big trap that everyone falls into is trying to fit that initial training data way too perfectly. And the lesson here? Don't get fooled by complexity. Simple often wins. Because when all is said and done, there is only one single metric that actually matters. Look, the number one most important thing isn't how fancy or complicated or advanced a model is. It is simply how well it performs on testing data. New data it has never seen before. That's it. That is the entire game. So now you know. You know the big secret. And that means you have the power to cut through all the AI hype you see online. It means you can ask the one question that really matters. So the next time you see some headline about a breakthrough AI that's going to change everything, what's the one question you should ask? You already know it. Just smile, nod, and ask. That sounds impressive, but how well did it perform on the testing data